you can see in this example, there are A, B, C, D. There are 4 nodes here. And each node, they are connected a branch. So in terms of the branches, you have 1, 2, 3, 4, 5 branches. The loop, we have 1 loop, 2 loop, and don't forget you have the 3rd loop here. So the first part of this work example is to ask you first assign the mesh current. We assume there's a current which passing along the loop we choose. Now remember, this current is not the real current. It may or may not be the real current. It's just a fictitious current. It means it's like a tool. And later we'll find out whether this current is really corresponding to the real current passing through the component in this circuit. This is the circuit after I draw the mesh current along the 2 loops. The first one is I1, and you can see I1 flowing along the left hand side of the loop, and the I2 follow the right side of the loop. So next, the question asks us write the KVL for each mesh in terms of I1 and I2. Now remember KVL, Kirchhoff voltage law. This is writing down is potential, rise or down, and there's a 2 sign convention. One is from the point of view of physicists. We are talking about how the energy increases or reduces. The other is engineering side. Now we use the engineering approach. Let's look at I1 first. The I1 here in this drawing, it enters the first voltage source from the negative side. So we write down the voltage of this source. So this is negative 10. Remember, you don't need to write the unit. It will save you a lot of time and will make the calculation a lot easier and neat. Second, when this mesh current I1 passes through the voltage source, it enters R1. Now think about if a current passing through R1 in terms of the potential, this must be high, this must be low, because current flow from the high potential to the low potential. So now, using the engineering sign convention, we say the mesh current I1 enter R1 from the positive side. So I will say, what is the voltage across R1? And at this stage, we don't know. But we still remember V equal to IR. So instead of writing the voltage across R1, we can say we use the current passing through R1 and then multiply the resistance of R1. So here we can say this become positive. Now you can say IR, but we know later I is the unknown, so we are going to solve I. So, and we know the value of R. So to keep the mathematics consistent or neat, we first put the R in this term. So I will put 1K. Again, you don't need to put unit. All you need to put is the prefix 1K, which represent the value of R1. And then you put the unknown I1. So you put I1 here. Next, we look at R3. You see this mesh current I1, it must passing the R3 from the high potential to the low potential. So we put positive here. So we expect this term must be positive. However, you see at the other side, we have I2. I2 is flowing opposite to I1. So what I mean is we can imagine there's another current opposite I1, so it will reduce I1, but still I1 passing through. So what really the current passing through R3 from this perspective is I1 minus I2. The sign minus because I2 opposite to I1. Now what is the value of R3? The same argument, which is 1K, and we know this is positive, and this is equal to 0. This is KVL, Kirchhoff voltage law, apply for mesh current I1. Now we're going to do the same thing. Write down the KVL for I2. It is a good habit. It doesn't have to be because it's a loop. So I always myself start from the power source. It means in this case the voltage. I2 enter V2, which is 30 volt from the negative side. So remember, you have to read it very carefully. So I will put negative 30 here. Negative 30. Next, it enter R3. Again, because we are looking at from the perspective of I2. So from the I2 point of view, this must be positive, this must be negative, and it means I2 must eventually passing through R3. However, from the point of view of I2, I1 is opposite it, so it means it reduces the magnitude of I2. So what is the actual current passing through R3? Which should be I2 minus I1 from the point of view of I2. So the voltage across R3, it should be I2 minus I1. This is the current from the point of view of I2. I1 is opposite to I2. This current multiply the value of R3, which is 1K, positive 1K. Put the positive here. So this is the term represent the potential across R3 with the engineering convention. Next, the mesh current I2 also passes through R2, and the value of R2 is 2K, and the potential across this one, of course, is plus 2K I2. So this is plus 2K I2. So you can say now we have two equations and two unknowns. The first unknown is I1, the second unknown is I2. And the aim is try to find I1 and I2. It means we solve this system of equations. There are many methods you can solve this system of equation. You can use elimination, substitution, or matrix determinant, whatever method you want. Now, before we solve the equation, I will first tidy up the equation because I want to rewrite equation 1 and 2 in the form which is a lot easier for us to solve in later. So what I mean is, we first look at equation 1. We got the first unknown I1 and I1. And you have 1K, 1K. So from equation 1, we'll get 2K I1. For the mesh current I2, we'll get 1K minus I2. So minus 1K I2. And I want to put the negative 10 to the other side of the equation. So this becomes positive 10. This is our equation 3. Now from equation 2, we'll say I1. Now this time it's negative I1 and its coefficient is 1K. So we have negative 1k I1. For the I2, we have 1k I2, 2k I2. They're both positive. We got positive 3k I2, and it is equal to 30. Now you can see we tidy up the equation a little bit like what you learned in high school. For example, in high school you always say 3x plus 4y equal to 5 minus 2x plus 4y equal to 8. So this is like a system of equation, but in high school you always use x and y or other symbols. Here you are doing engineering, so your variable become, in this particular case, I1 and I2. Here I just use elimination, and the elimination method look at the coefficient. Say I1, and I try to eliminate I1, and I find equation 3 for I1, the coefficient is 2k, and for equation 4 the coefficient is -1. So now what I can do is I can add equation 3 to equation 4, but if I want to eliminate I1, I have to multiply equation 4 by 2. So this is the method 3 plus 2 multiply 4. This 3 is equation 3, 4 is equation 4. By doing it, I1 eliminate. And now, how about I2? We can follow the rule. Equation 3, I2, the coefficient is here. So this is minus 1k plus, look at the coefficient, 2 times 4. So it means 2 times 3k. This is the coefficient for I2. And the same for the constant. So this is 10, equation 3, plus 2 times 30. Tidy up this one. We've got this is 5I2. And this is 70. Don't forget the k. Now, what's I2? I2 is now becomes 70 over 5k. Now we can look at the k here. Remember, what is k? K is a prefix. It just means 10 to the power 3. So just look at 1 over k. Just means 1 over 10 to the power 3. And this is 10 to the minus 3. And 10 to the minus 3 in terms of prefix is equal to m, mini. So there's a rule. And you can say 1 over k, if k is the prefix, it equal to m. M also a prefix. So that's very easy. And then you just deal with the number 70 divided by 5. And you will get I2 equal to 14 mini. This is why I got mini here. And remember, you have to put the unit ampere. The next part is find I1, of course. Here we can substitute I2 into whatever equation you like, and say I can into 3, into 4, or even 1 or 2. It doesn't really matter. Maybe I will say just 3. So 2k I1 minus 1k, I2 is 14m. You just bracket, put the value in, and you got 10. And can you see here? Again, we have a easy trick here. When k multiply m, k represent 10 to the power 3, m represent 10 to the minus 3. So you're doing about 10 to the 3 multiply 10 to the minus 3. And remember, your algebra is 10 to the power 0. So it is 1. So whenever you got k multiply m, in terms of the prefix, you always say sort of like a cancelling, but it doesn't mean they equal to 1. So 2k I1, this become minus 14 equal to 10. And of course, when you solve this equation, you will find I1 equal to 12 milliampere. So now we got I1 and I2. Now we find I1 equal to 12 milliampere, I2 equal to 14 milliampere. However, remember, I1 and I2, they are mesh current, and the mesh current may or may not correspond to the real current passing through the components along the circuit. So the mesh current is called fictitious. It means it's just like a tool. Next, we want to verify the KVL equation, if they are correct or not for these two solutions. KVL for mesh current 1, and this is minus 10 plus 1k I1 plus 1k I1 minus I2 equal to 0. Now we substitute I1 and I2 and check if they are equal to 0. Minus 10 plus 1k I1 is 12M plus 1k 12M minus 14M. Now again, whenever we see k as a prefix, multiply m as a prefix, equal to 1. So here we have minus 10 plus 12 plus 1k multiply minus 2m, and minus 10 plus 12 minus 2 equal to 1. So equation 1 is correct. KVL for mesh current 2, minus 30 plus 1k I2 minus I1 plus 2k I2 equal to 0. Minus 30 plus 1k, this is 14m minus 12m plus 2k, this is 14m, and minus 30 plus 1k, this is 2m plus 2k, 14m, minus 30 plus 2 plus 28 equal to 0. So KVL for both mesh current 1 and 2, they are consistent. Now we want to use the mesh current I1 and I2, find out the real current passing through the component. So let's first look at R1, and across R1 there's only one mesh current, which is I1. So for R1, I1 is the real current passing through it. So the current IR1, the current passing through resistor R1 is equal to I1, and it is equal to 12 milliamp. The voltage across R1 therefore equal to V. We can say 1 or R1 equal to IR1 R1, and 12M multiply 1K. So this is 12 volt. Let's look at R2. For R2, there's only one mesh current passing through it. This is I2. So again, the current passing through R2 is the mesh current I2, and it is equal to 14 milliamp. The voltage across R2 is IR2 multiply R2. It is equal to 14 amp multiply 2K, and it is equal to 28 volts. Now let's look at the current passing through R3. And remember, R3, there are two mesh current passing through it, I1 and I2. And I1 is 12 milliamp, I2, which is opposite, which is 14 milliamp. So the effect is the real current is 2 milliamp, but we have to remember the direction. The direction is from the bottom to the top. It means from D to B. So let's put it down here. IR3 this time is the difference between the two mesh current, I2 minus I1, which is 14 amp minus 12 amp equal to 2 milliamp. And make sure we put a note here, which is from the bottom to the top, or you can say from D to B. The voltage across R3, we can say VR3 equal to IR3 R3. So this is 2 amp, R3 is 1K. So this is equal to 2 volt. Let's summarize what we have. We know now the mesh current I1 is exactly the same current passing through R1, and this is from A to B, and this is 12 milliamp. The mesh current I2 is the same real current passing through R2, and which is same direction from B to C. So this is 14 milliamp. We also found the real current passing through R3 is the difference between I1 and I2, and this is 2 milliamp. And it is from D to B. Now let's look at note B. At note B, we want to check the KCL at B. So the KCL say the current flowing into the loop in this case is 12 milliamp plus 2 milliamp, and it should equal to the current flowing out of the node. And yes, they are indeed correct. So the KCL at node B is correct. Let's summarize the potential difference across each resistor. The potential difference across R1, we can put it as delta VR1, and we find this is equal to 12 volt. The potential difference across R2, it is equal to 28 volt. The potential difference across R3 is equal to 2 volt. Let's also mark which side is high, which side is low. For the R1, this is high, this is low. R2, high, low. R3, because now we know the current is from D to B. So the potential here must be high, and this is low. Let's consider if node C is ground, it means the potential at C is forced to be 0. So this point here will become 0. Now, Let's check for R2. This is 30 volt and this is 0. So I can say at this point, this is 30 volt. And this is consistent. This is 30 volt, 30 volt, the same voltage. Now we know the voltage across R3 is 2 volt and D is higher than B, so this must be 28 volt. R2, we just find the potential difference across R2 is 28 volt. So if the potential at B is 28, so the potential at C should be 0. So this is consistent. Now let's consider the voltage source 1 here. At this point is 30 volt. Now the potential E1, this voltage source, means it step up the potential. It add extra 10 volt. So at A, node A, the potential must be 30 plus 10 equal to 40 volt. Now let's check the potential difference across R1. So one is 40, one is 28. So the difference here is 12 volt. And this is exactly what we expect from our previous calculation. The potential difference across R1 is 12 volt. One side is 40, one side is 28 volt. Instead of put the node C as 0, if we ground the node D, it means we force the position here D as 0 volt. And in this case, we want to verify if this is consistent to all our measurement or calculation. For voltage source E1, it will increase the voltage 10 volt. So if this is 0 volt, so the voltage at A is 10 volt. However, we know the voltage across R1 is 12 volt. So A is higher than B, higher than 12 volt. So the voltage at B must be minus 2 volt. And if we look at the potential difference across R3, this one is 0 volt and B is minus 2. So it is consistent. It means now this time is 2 volt, but this time it's just from 0 to minus 2. The potential difference across R2 is 28. Now remember, this side is positive. So minus 2 minus 28. So you got minus 30 volt at C. And then E2 will step up the voltage 30 volt. So if this is minus 30 volt, as this is at C, passing through E2, minus 30 plus 30 equal to 0. So all values, they are consistent. This question is exactly the same as last one. However, if we change the direction of one of the mesh current, we want to see if we can get the same result. So this is how the two mesh currents show on the circuit. Now B, let's write the KVL for mesh current 1. KVL for mesh current 1. And again, for mesh current 1, it enters the voltage source from the negative side. And so this is negative. For any mesh current, if we enter a resistor, usually this is positive, this is negative. So we have 10 plus the current is I1, the R is 1K, so the voltage is IR, 1K, I1. So from the perspective of I1, this is positive, and this is negative. We also notice the mesh current I2 also flow from B to D. It means the same direction as I1. So we'll put I1 plus I2. The resistance is 1K equal to 0. KVL for I2. For I2, if we look at how the loop go into the voltage source, it's going from the positive side. So this time 30 volt must be positive. Positive 30 for the R2, which is plus 2K I2. And the same argument, when I2 passes through R3, is from the top to the bottom, and R3 1K, from the perspective I2, I1 flow to the same direction as I2. So this is equation 2. Next, we're going to solve I1 and I2. So let's first tidy up equation 1. And we'll get 2K I1 plus 1K I2 equal to 10. This is 3. From the number 2, we'll get 1K I1 plus 3K I2 equal to minus 30. Equation 4. Now we want to eliminate I1. The coefficient for the I1 is 2K in equation 3 and 1K in equation 4. So to eliminate I1, we can say 3 minus 2 times of 4. So I1 will be eliminated. So let's look at I2. So 1K minus 2 times 3K. And this is the coefficient for I2. On the right hand side, 10 minus 2 times minus 30. So here we'll find this is equal to 1K minus 6K I2, and this is 70. And you will see this is minus 5K I2, 70. From here, you will see I2 equal to 70 over 5K minus the same argument, minus 14 milliampere. Now, if we substitute I2 equal to minus 14 milliamp into equation 3, so you get 2K I1 plus 1K minus 14 M equal to 10. Again, Km become 1, and 2K I1 minus 14 equal to 10, and I put it here, 2K I1 equal to 24, and two K I1 equal to 24. So I1 equal to 24 over 2K, 12 milliamp. We find the value of I1 is 12 milliamp and the value of I2 is minus 14 milliamp. So it means I1 is exactly the same as last question. And I2 is negative 14 milliamp. It means the direction is opposite to the direction we assume. So this is the mesh current I2. It should also flow to the clockwise direction. If we're still following the I2 direction in this question, which is anti-clockwise, we will say its current is negative 14 milliamp. Next, let's check the KVL. KVL for I1, this is minus 10 plus 1K I1 plus 1K I1 plus I2 equal to 0. And let's check. Minus 10 plus 1K I1 is 12M plus 1K 12M plus minus 14M. And this is minus 10 and this is 12 because again K and M multiply become 1 plus this is positive 12 negative 14, so this is negative 2M and negative 2M we can say negative 2 and this is equal to 0. So KVL for mesh current I1 is correct. KVL for I2, so the equation say plus 30 plus 1K I2 plus I1 plus 2K I2. Now let's substitute both I1 and I2. Plus 30 plus 1K and I2 is minus 14M plus I1 positive milliamp plus 2K minus 14M plus 30. This one is minus 14 plus 12. So we got minus 2 and then this is minus 2. Again, the K and M, they multiply, become 1. This one become minus 28 and equal to 0. Let's calculate the current passing through R3. So R3, this is two current. One is I1 plus I2. I1 is 12 milliamp and I2 is minus 14 milliamp. So numerically, you got minus 2 MA. So it means it follows the negative direction of I2. So it means it's from the bottom to the top. And this is 2 milliamp. The potential difference across R3, which is VR3, equal to IR3 times R3. So let's just put the absolute value because we know which side is higher, which side is lower. So IR3 is 2M, R3 is 1K. Again, this is 2 volt. Of course, we know from here, this is positive, this is negative. The current passing through R1, IR1 equal to I1, so equal to 12 milliamp, and the voltage across R1, of course, is I1 R1. So again, 12 amp, 1K, this is 12 volt. Current passing through R2, this is I2, and this is minus 14 milliamp. It means the current flowing through R2 is in the opposite direction of the assumed mesh current I2. So it means in reality, this is the direction of the current passing through R2, and this is 14 milliamp. The potential difference across R2, VR2, is equal to I2 times R2. So this is, again, we use the absolute value, 14 milliamp, 2K, so this is 28 volt. Here I list the potential difference across R1, R2, and R3. In this part, we are asked if we put VC as 0. It means if we put this point here to the ground, and this equal to 0 volt. And we are going to check if we measure the potential at each node, are they consistent? If this is 0 volt, E2 will increase it to 30 volt. So it means this is 30 volt again, and this is 30 volt. E1 will also step up from 30 to 40 volt. R1, the potential difference across R1 is 12 volt. So it means at B must be 40 minus 12. So this is 28 volt. And the potential difference between R2 is 28 volt. So this is 28, this is 0. So these two numbers are consistent. And also the potential at D is 30 volt. From D to B, this is 2 volt. This is exactly the potential difference across R3. Now, if we force node D to 0 volt, it means we ground this one, and this becomes 0 volt. And we want to check what is the potential at each node. This is 0 here, 0. So voltage source E1, step it up to 10 volt. Again, if A is 10 volt, but the potential difference across R1 is 12. So at B is 10 minus 12. This is minus 2 volt. And minus 12. And this is 0. So the potential difference between D and B is 2 volt. We know the potential difference across R2 is 28 volt. So B is minus 2 minus 28. So this becomes minus 30. And again, the E2, it will step up the voltage from the negative to positive by 30 volt. So minus 30 plus 30 becomes 0. And this is exactly the voltage we assume. This circuit has two voltage sources, E1, which is 5 volt, E2, which is 30 volt. Now we draw the mesh current run clockwise, and the mesh current to anti-clockwise. So this is what the circuit looks like with mesh current 1 and mesh current 2. Now we want to write down the KVL for each mesh current. KVL for mesh current 1. Mesh current 1 enter E1 from the negative side. So this is minus 5. We have minus 5 plus 1K. This is the value of R1 multiply I1. So this is the voltage across R1 with the sign convention positive. For the R3, we notice there are two mesh currents passing through it, and they are parallel in the same direction. So the total current passing through R3 is I1 plus I2, and the resistor is 1K, so this is plus equal to 0. KVL for I2, and you can see for I2 the mesh current enter E2 from the negative side as well, so 30 volt must be written as minus 30. So this is minus 30, and this is positive 2K I2 plus, this time I1 and I2, they are parallel in the same direction. So similarly, I1 plus I2 bracket, and this is 1K equal to 0. This is equation 1 and this is equation 2. Next, we want to solve for I1 and I2. First, I will tidy up equation 1. Equation 1 will become 2K I1 plus 1K I2 equal to 5. This is equation 3. From 2, we have 1K I1 plus 3K I2 equal to 30. Equation 4. To eliminate I1, we noticed the coefficient of I1 for equation 3 is 2K, and for equation 4 is 1K. So we decided it should be a subtraction. So 3 minus 2 times equation 4 will eliminate the coefficient of I1 or I1 at all. So this will become 1K minus 2 times 3K. They are the coefficient of I2, and the same as 5 minus 2 times 30. So we have minus 5K I2 and minus 55. I2 equal to 55 divided by 5K. 1 over 5K become M. So we have 1 milliampere. Now we substitute I2 equal to 11 milliamp into equation 3. So we have 2K I1 plus 1K 11 M and equal to 5, and we have 2K I1 equal to minus 6 and I1 equal to minus 3 milliamp. So I1 is minus 3 milliamp. I2 is 11 milliamp. Because the sign of I2 is positive, so it means our assumption, the anti-clockwise assumption for I2 is correct. but I1, the value is negative. So in reality, the current for I1 should be flowing anticlockwise as well. Let us verify KVL for mesh current I1 and I2. For KVL for I1, which is minus 5 plus 1K I1 plus 1K I1 plus I2. So minus 5 plus 1K I1 is minus 3M plus 1K minus 3M plus 11M. So we have minus 5 and then we have minus 3. Again, remember K and M, when they combine, it becomes 1. And this is plus 1K. This become 8M. And we'll find K and M combine again. So we have minus 5 minus 3 plus 8 and equal to 0. So KVL for I1 is correct. KVL for mesh current I2. This is minus 30 plus 1K I1 plus I2 plus 2K I2. So we have minus 30 plus 1K I1 plus I2 will be minus 3M plus 11M plus 2K 11M. So this is minus 30 and this is again, this is equal to 8 and this is equal to 22. So again, it is equal to 0. So KVL for mesh current I1 and KVL for mesh current I2, they are correct. Now we want to calculate the actual current passing through resistor R3. So we call this IR3. On the circuit diagram, you can see it is equal to I1 plus I2. And I1 is minus 3 MA plus 11 MA. So the answer is 8 milliamp. And we just make a note here is from note B to D, or you can say from top to bottom. Now the voltage across R3 is IR3 and R3, and this is 8M 1K, and this is equal to 8 volt. Next, we want to calculate the current passing through resistor R1. So IR1, and if you look at the circuit diagram, the resistor R1 mesh current is the only current. So it means mesh current I1 is the current passing through R1. But remember, when we calculate the value of mesh current, it is negative 3M. So what it really means is the real current passing through R1 should be from B to A, which is opposite to the direction we assumed in the beginning. IR1 is equal to I1 mesh current 1 and is equal to minus 3MA. But remember, the meaning of minus sign just means is from B to A. The voltage across R1 is IR1, R1. Now we focus on the potential difference first. So the absolute value is 3M and R1 is 1K. So we got 3 volt. But remember, the voltage at B is higher than the voltage at A. Therefore, the current flow from B to A, and the potential difference is 3 volt. From here to here is 3 volt. The current passing through R2 is IR2 and is equal to I2, mesh current 2, and this time they are the same direction. And the voltage across R2, therefore it is equal to 11M 2K and equal to 22 volt. Now if we ground the circuit at node D, it means we force the D become 0. We want to write down the voltage and see if they are consistent with the KVL. D is 0, this is also 0, and this is also 0. For E1, it will step up the voltage from the negative to positive by 5 volt. So A must be 5 volt. For voltage source E2, it will step up the voltage by 30 volt. So at C, the voltage must be 30 volt. Now, let's look at V3. V3 is A volt because D is 0 and we know the current is flow from B to D. So B is at a higher voltage and therefore the voltage must be positive A volt. Now let's check the consistency. Between A, B is A volt and A is 5 volt. So the potential difference is 3 volt. This is exactly what we expect from potential difference across R1. The potential difference between C and B at C is higher than at B. So this is 30 minus 8 equal to 22 volt. So the potential difference between C and B is 22 volt, and this is exactly what we calculated before. So everything are consistent.